Um, Good day, grade 12 learners. Welcome to Physics 101. Okay, my name is Sekolin Ngcina, and in this video, we'll be doing last year's Physics National Paper. We will be particularly looking at mechanics. If you have any question, please comment down in the comment section below. I understand the frustration you might be going through. I was once in issues myself, but I don't. But don't worry, you have Science Services Echo in your corner. To be honest, really, because grade 12 and science might be very hard, and you might find that you don't have anyone who's here to assist you or to help you to demystify the problems and the challenges that you might be facing. So surely you have me on your corner. Rest assured, you have Science Services Echo on your corner, literally. Please like, subscribe to our channel, and also do not forget to share the video with your peers, because I understand they might be going through the same problems that you might be going through yourself. You see, because I know physics might be hard. So yeah, guys, this is the paper. It's National Senior Certificate, Grade 12 Physical Science, Paper 1. It's on November 2022. Guys, I'm gonna be doing all sorts of these questions, especially I know that you guys are doing grade 12, and some of you I'm gonna be writing physical science very soon. So yeah, guys, we're gonna be focusing on this paper. Basically, we're gonna be focusing on where we're gonna be focusing on pay question two. We won't do question one as of now, but we're gonna be focusing on applied mechanics question two. Right. So yeah, one thing that I also need to say is that this question is taken from this website, which is the Department of Education national website. You can find all these type of questions here. You just go scroll down and then go to previous exam papers here. Previous exam papers, you're gonna find your what? You're gonna find the grade 12 paper, either your maths, physics, life science, any question or any national subject that is examined by the Omalusi, you're gonna find it there. Right. The days that are left for grade 12 to write is what? It's 47 days, guys. You only have 47 days until you're right. So I urge you to start studying hard. Each and every day should count. Each and every day should count. At least for the amount of 24 hours that you're given in a day, make it a priority that at least 6 hours you covered. At least you cover 6 hours out of that 24 hours. 6 hours you cover it, and then the rest of the hours you can do whatever you want with the time. These 6 hours just focusing on your major subjects or the subjects that you have problems dealing with or problems understanding. Post on my on my post, comment on my section, comment on my videos, ask questions. Yeah, do anything that you can possibly that you can at this moment for you to be able to understand the content of your work. Because guys, it's I understand it's very hard, and also there's a lot of pressure that you have, and there's a lot of emotions that are involved. Whether you're gonna pass, you're gonna fail, am I gonna make it? Guys, all I can say is that you are here now, and you've worked hard for so long, and you've finally reached at this moment where you have to what? Just have to spread your wings and fly, guys. Basically, you've waited for this moment. You've never given up. Grade 10, grade 11, grade 8. Yet you work hard, and then you put a lot of pressure, a lot of hard work, and then you are here, guys. So please, I urge you, do not mess up this moment. Work hard as much as you can. Find people that can help you. Talk to someone. Don't just die alone. Don't be like what I used to be. Don't die alone, guys. Find people to assist you, because if you don't, it's gonna be too late, and with the time you wanna find help, it's gonna be too late for you. Okay, back to the content. So as I've said, we're gonna be focusing on the grade 12 paper, question two, and yeah. So this is the question that we're gonna do. So it's basically what the question says is that Question 2, start on a new page. It says crate P of mass 1,5 kg. So we have crate P of mass, which is equals to what? 1,25 kg. 1,25 kg. It says is connected to another crate Q of mass 2 kg. So there's also crate Q of mass what? Of mass 2 kg. Right. Is connected to another crate Q of mass 2 kg by a light inextensible string. The two crates are placed in a rough horizontal surface. A constant force F of magnitude 7.5 acting on the angle theta. So this is P. Constant force of F, which is 7.5 newtons, is what? Is acting on angle theta to the horizontal. So angle theta to the horizontal is applied on the crate as shown in the diagram below. Right, that's the first statement that it says. The second statement says the crate accelerates at 0.1 meters per second. So write all your given. Accelerated what? 0.1 meters per second squared. Write all your givens down. Write all your givens down. And it says down there it says crate P experiences a constant frictional force of what? Of 1.8 newtons. So this crate P so it says crate P experiences a frictional force of what? Of 1.8 newtons. 1.8 newtons. Right. And it says, and crate Q experiences a constant frictional force of 2.2 newtons. And crate Q experiences a frictional force of what? Of 2.2 newtons. 2.2 newtons. Right. So let's do the first question. The first question says 2.1. State Newton's second law of motion in words. You know that Newton's second law of motion is what? Is F net is equals to ma. To state this in words, you're just gonna say uh, when an applied force, let me just erase this. Let me just it says F net is equals to ma. It says when when in an applied force, when an applied resultant force, just change this. When an applied resultant force acts, when a force acts on an object, okay. The object will accelerate in the direction of the applied force. Right. It's like the acceleration okay, the acceleration no the acceleration of the object is directly proportional to the what? To the applied force to the applied to the applied force and inversely proportional to the mass of to the mass of the object. So Newton's second law says when an applied force acts on an object, the object will accelerate in the direction of the applied force, right? And it says again the acceleration of the acceleration of the object is directly proportional to the applied force and inversely proportional to the mass of the object. So the greater the applied force that you apply, the greater the applied force you apply on an object basically is the greater the object will accelerate. So that's it. There's nothing that's hard to it. And then if you don't understand that, you just need to memorize it. That's all. Then the second question says what? It says 2.2. The second question says draw a labeled free body diagram for crate P. Right. So now let's look at crate P. Let's represent it green white with the green color. Let's represent it with the green color. Right. So looking at crate P, which is this crate. So looking at crate P, which forces are what are acting on crate P? First of all, you know that there's a gravitational force that's acting on this object, and then they know that gravitational force is what is counteracted by what? By the normal force, right? And then and then also another force that is acting on object P, it's what? It's the frictional force that we're given. That is what? That we're given. That is 1,8 newtons, right? And then another force that is gonna be acting on object P is the what? It's the tensional force, right? So basically, to draw the free body diagram, it's easy. Just gonna say the object is gonna be represented by dot, and then you're just gonna write that down, which is gravitational force, which is gravitational force, and then another force that is gonna be acting there is Fg with this, and then it's a normal force, which is gonna be the what? The normal force, normal force that's gonna be acting on the object, and then it's gonna be that tensional force that is dragging object P, which is tensional string pulling force, which is represented by T. And then the last force that's going to be acting on object P is going to be the what? The frictional force, which is going to write here frictional force. So these are all the forces that are acting on what? On object part, on object P. So this is what? This is object P. These are all the forces, which is the what? The normal force, the gravitational force, the tensional force represented by the letter T, and the frictional force that we were told that it's what? That we were told that it's what? 1,8. Right. Moving right along. And then moving right along, let's say bring to the front. So moving right along on that note, we need to do the what? You need to do 2.3.1. You need to do 2.3.1 basically. Just gonna clearing out the space so that we have in enough space. So 2.3.1 says, it says that calculate the magnitude of 2.3.1, the tension of the tension in the string. So now how do you go about this? How to calculate the tension in the string? If you look at the tension, if you want to calculate the tension in the string, we're gonna be mostly focusing on what, to make it easy for ourselves to focus on what, on object P, right? So how do you go about that? So it says F net is equals to MA, right? F net is equals to MA, which is what, 2.3.1. 2.3.1, right? F net is equals to MA, right? So now we're going to look at what, at the forces that are what, are acting on what, on object P, as on the as on the free body diagram, right? So we said that the forces that are acting on object P, it's what, it's tension, which is equals to MA. The tensional force that is dragging what, object P that is dragging P forward or to the right, right? So what are the forces that are counteracting object P? It's what is the frictional force that is equal to M, which is the frictional force, right? So if the frictional force is counteracting what, is counteracting the direction at which object P is traveling, it's gonna be the what, it's gonna be the slowing down movement. So meaning that it's gonna counteract, or it's gonna subtract for the force from the tensional force, right? Do you understand what I'm saying? So let me repeat. What I'm saying is that the frictional force is going to be counteracting the object's P's force, right? So the frictional force, we need to subtract it from what? We need to subtract it from the what? From the overall force that is moving the object P to the front, forward. Basically, that's all that there is, right? So now what you need to do is simple, right? All you need to do is to plot your what, it is to put on your values. So it's T minus what, the frictional force that we for object P was what, was 1,8. It's 1,8 is equals to the mass of object P, it's what, it's 1,25, 1,25. Then the what, the acceleration is 0,1, right? So the second thing that you need to do now, we need to have what, we need to have one unknown. So it's gonna say T minus 1,8 plus 1,8 is equals to 1,25 multiplied by 0,1 plus 1,8, right? So basically what we're trying to do here, we're trying to to equate or to get rid of what, of 1,8, so that we can have one unknown, right? So we have one unknown on one side. Basically we want to have T as one unknown, right? So we remove what, 1,8 from the left hand side and bring to the right hand side. How do we go about that? We go about that by adding the value that we're adding the exact value, we're adding the exact value, because we know that this is gonna equate to what, this is gonna equate to 0, this is gonna equate to 0, right? So let's move forward. So now it's gonna be tension is gonna be equals to what, let's look at the power calculator, let's find a calculator, let's find a calculator. Let's find a calculator. It says what, it says 1,25, 1,25, 1,25 multiplied by 0,1, 0,1, right? The answer is what, it's 0,125, and then you add what, 1,8, 1,8, and then we have what, you have a tension of what, you have a tension of 1 comma, did I get that? You have a tension of 1,925, of 1 comma 925 newtons. So basically this is your answer for tension. So basically this is your answer for 2.3.1. Right, moving right along. We're gonna move to what? To our second question. Our second question says, I'm gonna write it here next to this. Our second question is what? It's 2.3 point. What am I doing? 2,3,2. Right. It says calculate the magnitude of angle theta. Right. Calculate the magnitude of angle theta. Right. So how do we go about this? The way we're gonna go about this is know that theta is on this, what is on object Q, right? So all I can advise for you to now is to focus on object Q. Focus on this object basically, right? So how are we gonna go about this? We know that the force that is being applied on object Q is applied at an angle and it's the resultant force. The force that we need so that we can calculate what the theta is to what is for us to get what is to get the what the fx is for us to get the fx of what of this resultant force, the fx component of the resultant force, or let me say the horizontal component of the resultant force. So how we gonna go about that? We're just gonna say fx is gonna be equals to, how we know most the trigonometric values, the cos, sine, tan, and all that, there is. We know that cos is what is adjacent of a hypotenuse, right? If it's adjacent of a hypotenuse, our adjacent is gonna be what? It's gonna be fx. Our adjacent is gonna be what? It's gonna be fx. Right, our adjacent is gonna be fx. This, our hypotenuse, it's what is the force, right? So how we're gonna go about that? We're just gonna say fx is gonna be equals to what? It's gonna be equals to f, which is the what? The resultant force that we're given, cos theta, right? Why? Why do I say that? Okay, let me write it here. The reason why I say that is because cos theta is equals to what? Fx over what? Over f, right? At and right angle triangle, right? So now we know that at the right angle triangle that cos theta is gonna be equals to fx over f, right? So for us to get the value of fx, we just need what to cross multiply. It's gonna be f multiplied by cos theta, which is fx, and then this one cancels, and then you're gonna be left with what? No, what am I saying? I'm saying that cos theta is gonna be equals to fx over f, right? And then for us to get the value of fx, we need to what? Multiply by f, and then also multiply by f this side. So fx is gonna be equals to what? F cos theta. So that's why that's where I got this value. It's what? It's one of those trigonometric values. That's why, guys, it's important when you're doing science to do pure maths, because these subjects are interrelated. Right, let's go to the question. So it's gonna be fx cos theta, right? So fx now is gonna be equals to, the value of f is 7,5 cos theta, right? And then we got the value of fx. Because we can't simplify any further because we don't have the value of theta. Now what you're gonna do is gonna say f net is equals to ma, which is mass multiplied by acceleration, right? Now we're gonna look at what? We're gonna look at object Q. We're gonna look at object Q. Which forces are acting on object Q, right? Right, now we have found the horizontal. Now we have found the horizontal component that is acting on what? On object Q. So it's gonna be the what? The horizontal force that is gonna be acting on object Q is gonna be what? Fx what? Minus what? Okay, let me pull up first. So it's gonna be Fx is equals to ma, which is what? The resultant force. Now this is gonna be the resultant force of what? Of object Q. So now it's gonna be Fx. Now we're gonna look at forces that are what? That are counteracting object Q. Alright. The forces that are counteracting object Q, that are dragging object Q down, is what? It's the frictional force of object what? Of object Q, and also the what? The tensional force. Right, is equals to ma. Why is the tensional force dragging? Why am I saying that tension is dragging? Is what is counteracting the forces that are propelling object Q forward. I'm saying that because the tension is what? The tensional force is the force that is dragging object Q down, because the string T is what is pulling it's pulling this force object P, and then pulling this object P drags what? It drags object Q object Q down, right? Because it's a force on its own, right? So yeah, that's all that I can say. So how we go about the question? The way we go about the question is, we're gonna what? We just gonna have to what? To plot now, to put our values down, right? So it's Fx minus the frictional force of object Q is what? It's 2,2 newtons minus 2,2. And then the what? The tensional force that we got is what? Is 1,928. 1,925, right? Is equals to the mass of object Q. It's what? The mass of object Q as given is what? Is 2 kg. And then the acceleration of object Q is 0, 1, because both these objects are accelerating at the same rate. Alright, so now we need the calculator. So basically now what you're gonna do is just gonna say minus 2, 2, which is the frictional force, minus the tension 1,925, which is what? Minus 4, which is fx, look at calculator, which is fx, uh, which is fx is what? Minus 4,125 minus 4,125. Let me just double check that. Minus 4,125 is equals to what? Is to equals to, let's multiply by 2 by 0, 1 and see what we get. It's gonna be 2 multiplied by 0, 1. It's gonna be equals to 0, 2, which is 0, 2, right? So fx now is gonna be equals to what? As I've said before, guys. Now we need to have one unknown. So what do we do? So minus 4,125 plus 1, plus what? Plus 4,125. This will equate to 0, right? 0, 2 plus 4,125, right? So since this will equate to 0, right? We want to have what? One unknown on one side, right? So it's gonna be what? It's gonna be fx is equals to what? Let's fx is equals to, let's look for the calculator. Hey, Now it's gonna be fx is equals to what? 0, 2 plus 4, 125. 0, 2 plus 4, 125, supposed to be 4, something. 4, 325. So it's gonna be what? 4, 325. Right. We are almost there, guys. We are almost there. We are almost there. So now we said that fx is equals to what? 4,325. Remember, guys, that we're not looking for the value of fx, right? And our answer is incorrect because our value of fx is equals to what? Our value of fx is equals to what? It is equals to 7,5 multiplied by cos theta. This is our fx. So now what we do, we take fx, which is what? 7,5 times cos theta. So now it's gonna be what? So now it's gonna be 7,5 cos theta is equals to what? 4,325. Right. And then what we do now, we're gonna divide by 7,5, and when we divide by 7,5 on the right also. Right. So what do we do now? Then we left with cos theta. Then we are left with what? We're left with cos theta. Cos theta is equals to what? 4,325 over 7,5. Right. 7,5. And then the value of theta now is going to be equals to what? Cos the negative function of what? Of 4,325 over 7,5. Right. So let's just find the calculator again and punch our values and see what do we get. So now it's just gonna say shift cos in your calculator, put on the fraction sign, 4,325 divided by 7,5 bracket, and then that's that. So now our answer is what? It's theta is equals to 54, what? Let's check the answer. It's 54,78 degrees. So now it's 54,78 degrees. So basically that's your answer, guys. That's your answer. Let me just elaborate more on what we did. That's the answer. So basically that's the answer. So what was the question again? The question was for us to find angle theta, right? Now the question is to find angle theta. Now in your mind you ask yourself, where is angle theta? Angle theta is on the object that is object Q, right? What am I given? I'm given the what? I am given the resultant force that is acting I'm given the resultant force that is acting on object Q, right? And I'm given what? And I'm given the friction, which is this is the friction, and I'm given acceleration, which is the acceleration, right? So what do you need to do? Now, for me to be able to use this resultant force or to be able to use it in my calculation, I need to be able to find the what? I need to be able to find the what? The fx component of the force, right? I need to find the what? The horizontal component of the force, okanye the force that is parallel to the ground, right? So how do you go about that? You know that your trigonometric ratio is that it's cos theta is equals to what? Fx over f over the resultant over hypotenuse, right? So now for you to get what? For you to get fx, I'm here. For you to get fx, you need to multiply by f on both sides, and then it's gonna cancel on this side, and it's cancel here, and you're gonna left with fx is equals to what? Fx is equals to f cos theta, right? And then that's where everything is gonna be easy, everything is gonna be demystified, everything is gonna just flow with the pace now, because after you found this, you just only gonna apply the second Newton's second law, and then after you apply Newton's second law, and then you're gonna be left with what? Fx is equals to ma, because your Fx, this force here is the what? Is the force that is pulling what? These two crates to forward, right? It's this force that is pulling these two crates forward, right? So yeah, guys, and after that, you find Fx is equals to ma. You know that what? You ask yourself, which forces are acting on what? Which forces are acting on object Q? Now you come again. Oh, the forces that are acting on object Q, it's gonna be the string, because the string is pulling object P backwards, and also it's gonna be the what? It's gonna be the frictional force. Then you apply, you put all your calculations here. Put your friction, you apply it, and then you could do a calculation here, and then after that you just then have to look for it, for the value of what? Of Fx. Look for the numerical value of Fx. Remind you that you're not looking for Fx, you're looking for the theta, right? So after you find the numerical value of your Fx, you're just gonna say, because you were saying that on our previous explanation, you said that Fx is equals to 7,5 cos theta. Now you're just gonna take 7,5 cos theta, and then you're just gonna plot it here, on the place of Fx, and then what? You look for the subject of the formula. We make theta the subject of the formula, you make theta the subject of the formula, and then you're gonna find your what? Then you're gonna find your coordinates, not the coordinates, you're gonna find your angle, yeah. So yeah, guys, thank you very much for listening. Please subscribe and like the channel, and also if you have any questions or thing that you want to be demystified, please comment it down in the section below. I pray for you guys. Please pass, please pass, please pass. Grade 12 is important, especially if you're black. You living in South Africa, grade 12 is important, guys. Especially doing science. You're gonna have many opportunities that are gonna open for you up. So yeah, guys, that's all I can say. Thank you very much, and God bless.